Section 7.4 is called the double angle and half angle identities. However, we're actually only going to focus on the double angle identities. We will not be talking about the half angle identities. Double angle identities have to do with what happens when you double an angle. So the first equation, sine 2 theta, so 2 times theta is doubling it. And the formula is 2 times the sine of theta times the cosine of theta. What I want you to notice is that there are 3 double angle formulas for cosine 2 theta. One of them is cosine squared minus sine squared. However, we don't use that one as much. We use the other 2 more frequently. One of them is 2 cosine squared theta minus 1, and the next one is 1 minus 2 sine squared theta. And the double angle for tangent, I want you to notice I wrote 2 formulas. This is the one the book gives. But because tangent is sine over cosine, it's actually much easier to use sine 2 theta divided by cosine 2 theta. So let's show you how the formulas work. If the sine of theta is 3 over 4, and theta has its terminal ray in quadrant 1, find the exact value of each function. Well, first of all, we said that the sine of 2 theta was 2 sine theta cosine theta. I know the sine of theta, it's 3/4, but I don't know the cosine of theta. So we're going to go back to something that we've done before, which is we're going to draw a triangle in quadrant 1. Terminal rays in quadrant 1. So here's your triangle. The definition of sine is opposite over hypotenuse. But since I need to know the adjacent side in order to find the cosine, we're going to use the Pythagorean Theorem in order to find the missing side, which happens to be x. So x squared plus y squared is equal to r squared. X squared plus 9 is 16. So x squared is 7, x is the square root of 7. So now I know this side. Now I can find the double angle for sine. 2 times sine of theta is 3/4, and the cosine of theta is the square root of 7 over 4. Well, this is just 3 fractions being multiplied together. Remember, when you multiply fractions, you multiply straight across. So when you multiply the numerators, you get 6 square root of 7. And when you multiply the 3 denominators together, you get 16. Now this can be reduced because 6 over 16 reduces to 3 over 8. So the sine of 2 theta is going to be 3 square root of 7 over 8. Now let's find the cosine 2 theta. It doesn't matter which of the formulas I use. Matter of fact, I could show you that all 3 of them work. But instead, I'm just going to do one of them. Because I know what the sine of theta is, and it does not involve a radical, I'm going to use this equation. So let's erase this. 1 minus 2, and then the sine of theta was 3/4. And because it's a squared, we're going to square it. Now this you could actually just plug into your calculator to get the answer, but I'm going to do it the long way. 3/4 squared is 9 over 16. And then I multiply that by 2, and I get 18 over 16. If you want to reduce that, you can, or you can just do 16 over 16 minus 18 over 16, which is negative 2 over 16, which reduces to negative 1/8. So the cosine of 2 theta is negative 1/8. To do the tangent of 2 theta, since tangent is sine over cosine, we'll do sine of 2 theta over cosine of 2 theta. And I already know those 2 answers. So we're going to do 3 the square root of 7 over 8 divided by negative 1/8. This is that case where we're going to multiply the fraction in the numerator times the reciprocal of the 1 in the denominator. These cancel, and I'm left with 3 the square root of 7 over negative 1, which is just negative 3 the square root of 7. This last one, sine 4 theta, it's not actually a problem in the book. I'll show you, but it's not going to matter for the homework. Really, it's the same as the sine of 2 theta. The reason I can write it like that is because 2 times 2 is 4. So it's really just a double angle within a double angle. So it's 2 times the double angle for sine times the double angle for cosine. And I already know these answers. So the double angle for sine, we got 3 square root of 7 over 8. Nope, wrong one. Yeah, no, that is it. 3 square root of 7 over 8. And the cosine of 2 theta, we got negative 1/8. And then we're just going to multiply those fractions together. So I get negative 6 square root of 7 over 64, which reduces to negative 3 square root of 7 over 32. Make that nicer. And that is all for the double angle formulas. They're really just a plug and chug. However, whatever the first trig function they give you is, draw your triangle, use the Pythagorean theorem to find the missing side, and then you can use your double angle formulas.